They asked us to sketch a graph of f of x equals -2 x minus 3 squared times x plus 1. So first, when we see this, I want to note the long-term behavior. So it's not multiplied out, but if I did multiply it out, the biggest term here would be x to first. If I took that term and I multiply it times the biggest term here that I would get if after I multiplied out x minus 3 squared, I would get the biggest term I would get there is x squared. So I know I would multiply an x squared times the x to first times -2, which doesn't add to the degree. So I know there's going to be a degree 3 polynomial. So then I think about the long, and I know it's a negative degree 3 polynomial. So I think about the long-term, long-run behavior of something like that. So I know y equals x to the third looks like an S shape, an increasing S. Then this function is going to be like something like negative x to the third. So I'm going to flip these and it'll be like a decreasing S. Now we can add, now I know that that's the general format of this line. However, now I can make this even more accurate by knowing exactly where these go through knowing exactly where the intercepts are. And I know the behavior around each intercept. So I know it's going to start high and start coming low. And it looks like it's going to hit the x-axis. And I set each factor equal to 0 here. So we know it's going to hit at x equals 3 right here. And x equals -1 right here. I want to keep in general what that equation was looking like, because I'll need that in a minute. But I know it's going through here and here. Now I can look at the multiplicity or the exponent on each factor. And it's telling me this looks like a bowl or parabola around the -3, around the +3 intercept. And then around the -1, it's going to be linear. So it's got to start coming high. And then it's going to come in high. It's going to go through like a line right here. Probably turn its direction, come up, touch 3, and then look like a bowl around that spot. And then head back down. So the long range behavior does match exactly the way I needed the long range behavior to match. We could even go one more thing here, and I could figure out exactly where it's hitting the y-axis, right? Let's find the f of x intercept, or y-intercept. So we could easily do that quickly by plugging 0 in for x. Oh, wait, that was 3. negative 3 squared. And times 1. So this is going to be, this is going to be 9 times 1 times negative 2. So this would be negative 18. So we expect that it's going to come, oh, it kind of comes down far here, like this maybe, right, at negative 18. And there we go, here's our graph.